All right, students. Now that we have completed our 45-45 special right triangle, it's time to get started on our 30-60-90, the second type of special triangle. Now, we say that the 45-45 was special because we had a special formula to use when we had a 45-45 degree right triangle. Remember that in a 45-45, the legs are congruent, and the hypotenuse is the leg times the square root of 2. Okay, so today we're going to explore our 30-60-90 triangles. Okay, so the other special right triangle is the 30-60-90. It's formed by bisecting any angle of an equilateral triangle. Do remember that in an equilateral triangle, the angles are all 60 degrees. They're all 60 degrees. Okay, what is the measurement of the bisected angle? So if we bisect an angle, we're going to make it perpendicular to one of the sides. Then what's the measurement of the bisected angle? So this one is 60. So if it's bisected, then that means it divides it into two equal parts. So the altitude of an equilateral triangle forms two right triangles. And these are our special types of right triangles, which are 30-60, 30-60-90. Okay, the longest leg is opposite the 60-degree angle. Okay, and the shortest leg is opposite the 30. And the longest leg is the square root of 3 times the size of the smallest leg. The shortest leg is always across from the 30. There's the 30, and that's the shortest. So we have to be able to find the different parts of our triangle so that we could use our formula. Okay, so the shortest leg, all the other sides are in relation to our short leg. So the short leg is the most important leg. Okay, because once we know that leg, then we can find the longest leg, which is the leg opposite the 60-degree angle. And it is the square root of 3 times x. And then the hypotenuse is 2 times the size of the smallest leg. Okay, so smallest leg, long leg. Okay, we'll call it short leg, long leg, and the hypotenuse. A special 30-60-90 triangle ratio. The longest leg is the square root of 3 times the size of the smallest leg. Okay, so first off, we have to be able to identify the short leg, long leg, and the hypotenuse. Okay, so don't look at the triangle and say, okay, this is the short leg and this is the long leg. Look at the information given, because it's not always drawn to scale. They want you to look and determine with the given information. Okay, so even though this one, that is the shortest, so x would be the short leg, and the side opposite the 60 is your long leg. So remember, the short leg is x, and the long leg is the short leg times the square root of 3, and our hypotenuse is twice as long as the short leg. Okay, so the longest leg. So these are our... Okay, guys, now that we've gone over the preview for our 30-60-90, there are a few examples I'd like to go over with you. Okay, the first example is our 30-60, where our short leg is 12. Now, when given these problems, you notice that it is a 30-60 degree right triangle. Okay, so what I would like to see you do is to identify the long leg, the short leg, and so forth. So remember that opposite the 30-degree angle is our short leg. So I'm going to abbreviate with an SL. Okay. Opposite the 60-degree angle is our long leg. And opposite the right angle is the hypotenuse. Okay. So once we identify those three sides, then we can use one of the formulas to determine the remaining sides. Okay, now we're given the short leg. So this one is going to be pretty easy. Remember that whatever the short leg is, in this case it's 12, then we take that leg and we multiply it times the square root of 3 to get our long leg. So therefore, the long leg is equal to 12 square roots of 3. The hypotenuse is equal to the short leg times 2. So the short leg is 12. We multiply that times 2, and we get 24. Okay, so x is equal to 12 square roots of 3, because x is the long leg, and y is our hypotenuse, which we take the short leg 12 and multiply times 2, and we get 24. Okay? All right, now, what if we start off with the hypotenuse? Here we have started off with the hypotenuse. The hypotenuse is 8. The long leg is y, and opposite the 30-degree angle is our short leg. Okay, now remember, we're trying to find the short leg and the long leg, and mostly everything is defined according to our short leg. Okay, so let's find the short leg. Now it says that the hypotenuse is equal to the short leg times the square root of 2. Now when we're looking for the short leg, then we have to divide. Okay, so it's going to be the opposite. When given a short leg, we multiply. When given the long leg or the hypotenuse, we have to divide. So I'm going to give you a couple more formulas, or at least one more. If you're looking for the short leg and you're given the hypotenuse, then it's really simple. All you have to do is just divide it by 2. Don't get it confused with dividing by the square root 2, which is your 45. But you just divide it by 2. Real simple. Okay, so there's a fourth formula or equation that you'll need to use. So to find our short leg, which is equal to x, I'm just going to abbreviate the short leg. We take the hypotenuse and divide it by 2. And that gives us 4. Okay, so the short leg is 4. And then once you find the short leg, then remember that the long leg is equal to the short leg times the square root of 3. And remember that our short leg is 4. And then we just multiply times the square root of 3. Okay, so that's how we get our long leg. And the long leg is our y value. Okay, so x is equal to 4, which is our short leg, and our long leg is 4 square roots of 3. All right, now last practice problem, and that is when given the long leg. So we identify, and our given information is the long leg. Notice that this is not drawn to scale, so you can't just look at it and come up with your short leg and your long leg. We want to use the rules. Opposite the 30-degree angle is your short leg, and opposite the right angle is your hypotenuse. Okay, now I'm going to give you a fifth formula for this one, even though you can solve for the others. The long leg remember, the long leg is equal to the short leg times the square root of 3. Now, if we're looking for the short leg, let's say that we're looking for the short leg, given the long leg, then we will have to divide. So we'll take the long leg and divide it by the square root of 3. Short leg is equal to the long leg divided by the square root of 3. Okay, so we have, we're looking for the short leg, so we're going to use the formula. Short leg is equal to the long leg divided by don't fail me now, divided by the square root of 3. Okay, now the short leg is x, the long leg is 18, and we divide that by the square root of 3. Now, if you can do that much of it, great. But the majority of you, I want you to be able to rationalize. And I want everybody to know that this is not simplified. We cannot leave a radical in the denominator. So what do? We rationalize. What does that mean? We take whatever in the denominator, the radical that's in the denominator. That's the square root of 3 this time. We multiply it to the top, the numerator, and the bottom, the denominator. Because remember, that's 1. Okay, and then we multiply across. Don't worry, it's okay. You just want to do one step at a time. It's okay. So we multiply across. 18 times the square root of 3. And remember, the reason why we multiply the square root of 3 in the first time is to get rid of the radical. Okay, so we're getting rid of the radical. The radical is no longer there, and our denominator is 3. And do notice that I have 3 and 18 on the outside, so that means I can divide those. So 3 goes into 18 6 times, but my square root of 3 is still there. Okay, so basically what I've done is just divided the 3 into the 18 to get my 6, and my square root of 3 is still there. Okay, well, good luck. All you have to do is use these 5 formulas, and you will be able to find any of the missing values of a 30, 60, 90 right triangle. Good luck. Our